Today we're going to be talking about some tests for convergence. And we have the nth term test, geometric series, and alternating series tests today. So our first test, the nth term test for divergent. So if the limit of the function that you have inside your summation does not equal 0 or fails to exist, then our function diverges. It doesn't necessarily converge if it equals 0, if your limit equals 0. We can just say that it diverges. So notice how this is a test for divergence, not necessarily convergence. Okay, so our first example here. Determine whether the series converges, justify your answer. So the limit as n goes to infinity of this function, that limit equals 1. And since my limit doesn't equal 0, fails to exist, so my limit doesn't equal 1, so therefore my series diverges by the nth term test. So you need to tell me series either converges or diverges, and you need to state the test. That's going to be really important to us. Geometric series. Now, if you're sitting in my class, we've already kind of talked about geometric series. So just remember that your ratio keeps going up and up and up. And you converge only if the ratio that you have is between -1 and 1. And then remember, the sum is this formula. We've been doing these. I just wanted to make sure it was super clear to you guys. Always try and look for a geometric series when you're going through the problems. So find the radius and interval of convergence for this series. So looking at this, we know this is geometric because I have some function to a power, and that right there is my radius. So my ratio has to be between -1 and 1. If I multiply both sides by 3. Add 1 to both sides. I don't know why I'm struggling with adding 1 to both sides. I had to check in my notes. Now divide by 2. So this is the interval of convergence. Finding the radius of convergence. So to find the radius, you have to figure out what the center is. And your center is halfway in between the two values, and our center in this case is 0.5. So the radius is from 0.5 to either one of the endpoints. So our radius ends up being 1.5. Okay, next, alternating series tests. We use this a lot. Eventually, I'm going to give us a tool where we're going to be finding the interval of convergence for these series. And we're going to be using this alternating series test a lot when we're looking to figure out if the endpoints actually converge. So we have our alternating series test here. Okay, so we have a function where one's positive, one's negative, one's positive, one's negative, one's positive, one's negative. And each term is progressively getting smaller. So that's what this means, is each term is progressively getting smaller. And you're going to converge if each term is progressively getting smaller and the limit of just the function here goes to 0. Okay, so again, each term is getting smaller, and the value is going to, the limit of our function is going to 0. So determine whether or not the series converges or diverges. So for the first one, first lay out a few values showing that it is alternating and that the values are getting smaller. So if I plug in 1, I get a positive value, I get a positive 1. If I plug in 2, we have a negative 1/2. If I plug in 3, we have a positive, and so on. So you see each one of our terms keeps getting smaller. The absolute value of them keep getting smaller. So now I need to show that the limit as n goes to infinity of 1 over n. What is that value? That value is 0. So therefore this converges, and you have to state the test by the alternating series test. And I don't want you to abbreviate it any more than that. Please use alternating series test so that it's not only clear to me, but clear to AP readers when you get to the AP. Okay, the next one. If I plug in 1, I have a 2 over a 1. If I plug in 2, I have a negative 3/2. Plug in 3. I have a 4 over a 3. Plug in 4. 5 over a 3. So these over a 4. These terms are progressively getting smaller. Okay, so just make sure you realize that the terms are getting smaller. So it verifies the first one, or first part of our alternating series test. Now we find this limit. This limit actually equals 1. So since my limit didn't equal 0, this diverges by the nth term test. And so that is the tests that we are going to talk about, or we have just talked about today.